Alright, so we are doing the last problem in 4.5, and it is a growth and decay type of problem. So we are going to complete the table for the population growth. Now you have the notes, so you can just kind of follow along and make the notes as you want. So in millions, we have the 2005 population at 43.5, the projected 2004 population at 38.3, and the projected growth K is what we need to figure out. So how are we going to do this? Well, if we use our standard type of decay formulas, if it's projected to be 2004, the population, and that should be 2024, so sorry, 2024, then we're going to take that 38.3 is going to be equal to the population that we have raised to the e power to k times how many years is it between 2024 and 2005. So if we take 2024 minus 2005, when we subtract that we get 19. So 19 is our t. This is equal to the t. Now, this is coming from the formula that you use for the growth. And in case you don't remember, or you weren't here the day we did that, that is using this formula here. That P of t equaled the P of O, or P sub naught is what they're calling that, e to the kt. That was the formula that we used when we did part of this in class. So using that formula, we've plugged in that in 19 years, this would be what our population is. This is where we started with the population, the P naught. That's when our time was at 0. Our K is what we're looking for, and T is the 19. So how do we solve this? Well, we've got to solve for K. So we're trying to get K down into the the base of the equation. We can't leave it in the exponent to solve it. So we're going to do things that we've similarly done. So we're going to do 43.5, going to divide by that on both sides. So that'll get us 38.3 over 43.5. Do not try to put that into a reduced part, just leave it alone. So it'll cancel over here, and that leaves us with e to the k times 19, or 19k. You could rewrite that as 19k. So now we need to get rid of the e. So to undo the e, we use ln. So what we do to one side, we do to the other. So we're going to take the ln of both sides, and this will be, I'm going to change that to 19k just because it's more natural to be that way. So now that'll take care of the ln, will undo the e, so that'll leave us with ln of 38.3 divided by 43.5 is equal to 19k. Well, to solve for k, we are just going to divide both sides by 19. So we've got ln of 38.3 divided by 43.5 divided by 19 will equal our k. Now when you plug that in your calculator, you should get that k is equal to negative 0.0067. Okay, and that's an approximation with your little curvy bumps. Why? Because it is a rounded off decimal. And you want to do this to 4 decimal places. So that finishes 4.5. The next thing we're going to do is a problem from 5.1. In 5.1, we have the revenue and cost function, the profit function, and we have the equation of C of X where we kind of put them together. So the revenue and cost function is the price per unit sold times X, And the profit function will be P of x is equal to R of x minus C of x. Here's our R of x, here's our C of x. And C of x is equal to the fixed cost plus the cost per unit produced times x. So the break-even point is where the money coming in equals the money going out. If this was on a graph, this would be a point of intersection. The point of intersection. Okay? That's why it's called a break-even point. All right. So this is our problem here. We've got company that produces wheelchairs. It has a fixed cost of $500,000, a production cost of $400 per chair, and the wheelchairs are sold at $600. So if we're going to write the cost function C, so we're looking at C of producing X wheelchairs. So that means that C of X equals the fixed cost, and the fixed cost is $500,000 plus the cost per unit sold, which is $400. And how many that's being sold is going to be X, so 400X, because that's telling us how many chairs we actually have sold. Okay, so the next thing is we are going to write the revenue function R from the sale of the X wheelchairs. So if we're looking at doing R, we have the price, so R of X equals the price of per unit sold, which is $600, times X. So here we have 600X. Now, if we want to find the break-even points, then we're going to take each of those, because C of X can be written as the same thing as Y. So if C of X is equal to Y, then we can say Y equals 500,000 plus 400X. And if we also have the R of X, well, R of X equals Y also, right? It's a function. F of X equals Y, C of X equals Y, R of X equals Y. So if R of X equals Y, and it also equals 600X, we have two equations here, both equal to Y, and we're going to do substitution. If this one equals Y and this one equals Y, then they must equal each other to create our breaking point. So we're just doing substitution. So this is going to get us, we'll just put the 600X on this side, is equal to 500,000 plus 400X. So what do we got to do to get X by itself? We'll move this side over. So 200X equals 500,000. Divide by 200. And X will equal, well, the zeros on the edge are going to cancel out. So we've got 5,000 divided by 2. Well, that'll get us 2,500. So that's the first part. We've got the 2,500. But now this is kind of like the vertex, right? Remember, we got one part and we had to plug it into the other part? So we're going to take that 2,500 and we're going to plug it back into our original function. So that means I'm going to take 2,500 and plug it into the R function. It'll be the easiest one. Let's see. So if we take, put that on the next sheet, I think. So we will take R of X and we're going to plug in that 2,500. So we're going to actually do R of 2,500 is equal to 600 times our X, which is 2,500. And when you do the math on that, you're actually going to get 1,500,000. So our breaking point will be 2,500, comma 1,500,000. Okay, so this means that the money coming in will equal the money going out. The last part we're going to do is called the profit function. So part D is the profit function. So the profit function is our P of X one. So this will get us P of X is equal to, this was the R of X minus the C of X. So R of X was 600 X minus C of X, which was 500,000 plus 400X. Now, if you're wondering where that came from, let me pull this up here. So our R of X was equal to 600 times X, and our C of X is equal to 500,000 plus 400X. So I took these two and I plugged them in right here. So here's our R of X, here's our C of X. I put it in parentheses because we have that minus sign. So 600X minus 500,000 minus 400X. So this will get us, combining like terms, 200X minus 500,000. So that is our profit function. And that will be the end of 5.1.